Okay, listen. Today we are going to see how to solve system by linear system of nonlinear equations. But before the topic, I want that everybody be clear what we are looking for. Okay? Then we have we have we have these three shapes, the three of them, the equation of three of them are quadratic equations. Okay? And quadratic equations are equations that are non-linear. Quadratic, okay? Are non-linears. Then, when we saw linear equation, the graph is a line. But these ones are different graphs. When we solve a system of nonlinear equation, we are looking for the intersection point between two of them, any of them. For example, if we have this and this, we have the equation for this, we have the equation for this. When we solve the system, we are looking for these four intersection points. Okay? But sometimes we don't have two. We don't have four, I'm sorry. We have only two. For example, if we have this and this, we have only two intersection points, this and this. That is the second possibility. The another possibility is that when we have, for example, this situation, how many intersection points we have here?
One.
Only one is right here. Or can be something like this. Oh, sorry. Something like this and this. We don't have any intersection point between these two graphs, then we don't have. Then here we have four solutions. Here we have two solutions. One solution, and here, no solution. Then I give you this because I want that everybody has an idea when we solve a system what we are looking for. We are looking for the intersection point. All right? Then what is the topic today? Is how to solve nonlinear system, but we are going to see by this method, that is addition. All right? Then, and this, remember that when we solve linear equation, addition, in some textbook, they call elimination, but it's the same, okay? Addition or elimination method is the same. We are going to see three examples, all right? Then number one is that, how we build by addition, or elimination, I need to try to eliminate one of the variables. As you can see here, we have a coefficient here that is 4, here is 1, here is 1, or here is 1, okay? Then we have different ways to solve that system of nonlinear equation. For example, one way is I multiply the first equation by 1 and the second equation by -4, we can eliminate x. But the easy way is to multiply the second equation by what?
4.
No, the second equation by
-1.
by -1. All right? By -1. If we multiply the second equation by -1, that is the easy way because we can eliminate y, the y's. All right? Then the first equation by 1, then it will be the same. That will be 4x squared plus y squared equals 13. And when we multiply the second equation by -1, will be minus x squared negative y squared equal -10. And now, what we do? The same that we did when we do the elimination with linear equation. We add the two equations. Eh? Then 4x squared minus x squared,
4. 3x.
3x squared. Y squared, negative y squared, cancel. And 13 minus 10 is equal to 3. All right? Then now divide both sides by 3. Then x squared is equal 1. X is equal what?
1.
1/2.
No? How can I eliminate the square?
Oh.
Square root. Then before to continue here, if we have a square root of 16 is equal what?
4.
Only 4?
-4.
Remember that when anytime that we find the square root of a number, we have two possible solutions. We have positive 4 and negative 4. We have two solutions. What happened that many times we don't use the negative part. We use only the positive, but anytime, and everybody know why, no? 4 squared is 16, but negative 4 squared is 16 too. Then for that reason, the square root of 16 is positive 4 and negative 4. For that reason, here the square root of 1 is what?
Positive and negative.
Positive and negative. We have two possible solutions there. All right. Okay, we found already the value of x. We need to find now what? The y, the value of y. All right. Then for that, how you can see, we can use any of the two equations. Substitute x equal 1 and x equal -1 in any of the two equations. But the easy one is the second. All right? Then another thing that you need to know. If we plug in 1 here, 1 squared is what?
1.
Is 1. But if we plug in -1 squared is what?
1.
Then we don't have to do 2 times, we do only 1 time because it's the same. Okay? Then we are going to substitute x, in that case, positive or -1, any of them in, let me call equation 1 and 2, in the second equation, in 2. All right? Then, x squared plus y squared equal 10. Then x is equal 1 or -1, you take any one of them. 1 squared plus y squared equal 10. 1 squared is 1 plus y squared equal 10, subtracting 1 from both sides. Then y squared is 9. And y is what? Positive and -3, remember that. Alright? We have two solutions. Then that is the square root of 9, that is equal positive and -3. And that is the two value of y. Then what is the problem when we have a system of nonlinear equations? Then you say, well, how many solutions we have here? Look, we have positive 1 and -1, no? And here we have positive 3 and -3. One solution is going to be 1, 3. But another one will be -1, 3. Okay? And after, positive 1, -3, and positive 1 and positive 3. Then we have 4 possible combinations there. When the final answer is this solution. Is the first solution can be 1, 3. No? The another one can be 1, -3. The another one can be -1, 3 and -1, -3. All right? Then, if we do the graph of that two equations, we can use a graphing calculator to do that if you want. It's right here. Can you tell me the equation? It's 4x squared, no? 4x squared, 4x squared. What is that? 4x squared?
Plus y squared.
Plus y squared, no?
Yeah.
Plus y squared equal
13.
13. So this is the first equation. Then let's see the second. What is the second? X squared, no? plus y squared equal 10. Look. Look the intersection point. Negative 1, 3. 1, 3. You see the whole solution? 1, negative 3, and negative 1, negative 3. That's the four possible solutions that we have, and the intersection between the two graphs. No problem with the first example? Okay? Can I continue?
Yes.
Mr. Cesar? Okay, let's see. If you don't have question with that, let's go to another example. Look this one because this one is different. We have this is a parabola, and this is cycle. Then let's see how many intersection points we have between the two graphs. All right. Then we are going to use the substitution method, the elimination method. Then for that reason, we need to organize the first equation first. It's the first thing that we have to do. Okay, then we need to move x squared to another side. If we move x squared to another side, will be what? Negative x squared, no? Then, if we organize the equations, that will be negative x squared plus y equal 3. And the second equation, I don't have to do anything with that. Look, that is a very easy system. Because we have negative x squared and x squared, then we don't need to multiply both of them by 1. Then we can add both of them. System. X squared and negative x squared, cancel. Y, in that case they are different. Y squared plus y equals 12, no? And you know that this is a quadratic equation. Then, but what happened? We need to organize the quadratic equation. Then we need to move 12 to another side. Then subtracting 12 from both sides, no? Subtracting 12 from both sides, the equation will be y squared or y minus 12 equals 0. And now, we use any different way that we have to factorize that to solve it. But in that case, I advise to you to use the method that I showed you before to find two numbers that multiplies are equal negative 12 and the same number when we add them are equal 1. You remember that? Okay? Two numbers that multiplies are equal negative 12 and when we add them are equal 1. Which two numbers can be?
4 and negative 3.
4 and negative 3. Alright? 4 multiplied by negative 3 is negative 12 and 4 plus negative 3 is equal 1. Okay, Graciela? Yes, sir. Then the two equations will be y plus 4 and y minus 3 equals 0. Then y plus 4 equals 0 and y minus 3 equals 0. Subtracting from both sides, y is equal negative 4 and y is equal 3. Now, then, now this is the value of y. We need to find the value of x. Okay? Then, we use any of the two equations. I'm going to use number 1. Okay? Let's see y equal x squared plus 3. Then y is equal negative 4. Negative 4 is equal x squared plus 3. Subtracting 3 from both sides. Then x squared is equal negative 7. And x is equal the square root of negative 7. What happened with the square root of negative 7? We can find the square root of the negative number?
No.
Well, in the complex number, yes, but we're not complex number right now. This is the real numbers, okay? Then, this, if we find this in the calculator, say error, then for this, there will be no solution. This value of y and this value of x. Let's see for y now. Y, then we do the same, no? Y equal x squared plus 3, that is 3 equal x squared plus 3, subtracting 3 from both sides. X squared is equal to 0, everybody know why, no? 3 minus 3 is 0. Then x is equal to the square root of 0, and the square root of 0 is what? 0. Well, in that case, yes. Then how many solutions we have? Only one. That is the solution is 0. Remember that is x first and y second, 0, 2. Then the intersection point between the two graphs is that point. Let's do the representation too very fast using a graphing calculator to see that is the solution. All right? No question about it? Okay, let's see to graph these two. Can you tell me the question because I cannot memorize y equals x squared plus 3. Say y equal x squared plus 3. No? That is the first one. That is a parabola. And the second?
X squared plus y squared equals 9.
X squared plus y squared equal 9. Look, the solution. Intersection between the two graphs is 0, 3. All right? Okay. Number 3. Can I go to number 3? The last one. That one is very easy to do because we have y squared positive and y squared negative. Then, and to apply the addition method, we don't need to multiply by nothing because it's already one is positive and the same coefficient. And we have x squared plus x squared is 2x squared. This cancel, and 13 plus 5 is 18, no? Divide by 2. Divide by 2. Then x is equal to square root of 9. Then the value of x are positive and negative. Then I can use any of the two equations. I am going to use equation number 1. And 3 squared is 9 and negative 3 squared is 9 too. I use only one. I don't need to use both of them. Then substitute x equal in, I am going to use equation 1. In 1. But I can use 2 if I want to. All right, equation 1, x squared plus y squared equal 13. Then the value of x are 3. Then 3 squared plus y squared equal 13. That is 9 plus y squared equal 13. Subtracting 9, y squared equal 4. And y is equal what? 2. Square root of 4, that is positive and negative. All right? Then now we need to write the solution. Remember that we have a combination between positive negative 3 and positive negative 2. That can be 3, 2, 3, negative 2, negative 3, 2, negative 3, negative 2. Then the four possible solutions are 3, 2, 3, negative 2, negative 3, 2, and negative 3, negative 2. Okay? Any question, any problem? Okay, let's see the graph very fast. And see that 3, 2, 3, negative 2, negative 3, 2, and negative 3, negative 2 are the solution. What is the first equation? X squared, no?
X squared plus y squared equals 13.
Equal
13.
13. And the second?
X squared minus
Minus.
y squared equals 5.
Equal 5. You see? Negative 3, negative 2, negative 3, 2, 3, 2, and 3, negative. Okay? This, you don't know what is the name of that. Anyway, you will know in the future what is the name of this graph. Okay, that is in the syllabus for this class. All right? If you don't have question, you can try now this example. Try this one now, please. And if you have any question, let me know.
Yes, sir.
Thank you.
Yes, sir.